Hello students, in this lecture you learn the Lorentz transformation of velocities. So far what we had seen was Lorentz transformation equations. They are the equations for the positions, that is the distance. Here we'll differentiate those positions to get the velocities. Then the equations are known as Lorentz transformation of velocities equations. See, as I mentioned in the previous slide, we will consider Lorentz transformation equation and then we'll differentiate them. So what are written here are the Lorentz transformation equations. One is the x dash equal to x minus vt divided by root of 1 minus v square by c square, y dash equal to y, z dash equal to z, and t dash equal to t minus xv by c square divided by root of 1 minus v square by c square. First we'll try to calculate Lorentz velocity equation along the x-axis. So we require here now two equations of Lorentz transformation. X dash equal to x minus vt divided by root of 1 minus v square by c square, and t dash equal to t minus xv by c square divided by root of 1 minus v square by c square. So when you differentiate this x dash with respect to t dash, dx dash by dt dash, so that is nothing but ux dash. So velocity observed in the second frame along the x-axis. So what we do here is we substitute for x dash is equal to x minus vt divided by root of 1 minus v square by c square, and t dash is t minus xv by c square divided by root of 1 minus v square by c square. Now this root of 1 minus v square by c square is constant, so it will come out of the derivative in numerator as well as denominator, and they will get cancelled out. And then you differentiate the numerator. What is there in the numerator? What is there in the denominator? So here dx minus vt is dx minus v is constant dt. So dt minus v is constant, c square is constant. So v by c square dx. Then divide numerator and denominator by dt. So what you get here is in the numerator dx by dt minus v. The dt and dt cancels. So what remains there is v. Then here when you denominator is divided by dt becomes 1, so minus v by c square dx by dt. Now dx by dt is nothing but velocity as measured in the first frame, so it is ux. So we write here ux minus v and 1 minus v by c square ux. Then next we will find dy dash by dt, which is uy dash. So we substitute y dash equal to y. See, the Lorentz transform equation for y dash and t dash is given, and t dash equal to this quantity t minus xv by c square divided by root minus 1 minus v square by c square. Then this root of 1 minus v square by c square is constant comes out. It is then the denominator of denominator, so it will go into the numerator. So you get dy root of 1 minus v square by c square divided by dt minus v by c square dx. Then you differentiate numerator and denominator by dt. So what becomes here is dv by dt, and this dt by dt is 1, so dx by dt comes here, and dy by dt is nothing but uy, and dx by dt is nothing but ux. Similarly, we will find dz by dash by dt dash to get uz dash, and we have given here the Lorentz transform equation for z dash and t dash. And when you simplify, as you have done in the previous slide, you get the uz dash equal to uz root of 1 minus v square by c square divided by 1 minus v by c square ux. Now what we have found in the previous three slides, now we are bringing here together, and they are Lorentz transformation of velocities equation. So one equation is for ux dash, other is for uy dash, and other for uz dash. Then to get the inverse Lorentz transformation of velocities equations, we consider the Lorentz transformation of velocity equation and substitute there v by minus v and primes by unprimes. Prime means dashes. Where the dash is there, you replace it by no dashes. And unprime by prime, that means where there are no dashes, replaces by with the dash. So this equation here, we replace dash by no dash by dash, and v by minus v and we get this equation, the equation ux equal to ux dash plus v divided 1 plus v by c square ux, and ui equal to ui dash root of 1 minus v square by c square divided by 1 plus v by c square ux, and uz equal to uz dash root of 1 minus v square by c square divided by 1 plus v by c square ux. Now these are inverse Lorentz transformation of velocities equation. See, the Lorentz transformation of the velocities, all those equations we had found in order to get what is called Einstein's law of velocity addition. In Einstein's law of velocity addition, there are three frames. See, first frame S, second frame S dash, third frame S double dash. Then, as it is shown here, the second frame moves with respect to first frame with the velocity v toward the right. Then the third frame moves with the velocity with respect to second frame with the velocity w, and third frame moves with respect to the first frame with the velocity u. Now let us see what are the meaning of this three frame. Now take the example, observer is there on the earth, then observer is there on the earth and observing, that means earth is a frame S, first frame, then aeroplane, let us say that it is open on both all sides, or it is glassed, just like helicopters. There are big glass panes are there. So that is a frame S dash, and that helicopter is moving with respect to the earth with a velocity v. So helicopter or an aeroplane is a second plane, a second frame, and earth is the first frame. Then inside the aeroplane, let us say insect is also moving. Insect is moving. See, for observer in the plane, he will see that insect is moving and it is moving the velocity w. Then observer on the earth, see, for him both uh, aeroplane is moving and the insect is moving, but not at the same velocity. So, what will be velocity for the observer on the earth? The velocity of that of insect with which it is moving. That's what we want to find out. Okay. So here what happens is there are three frames. So now, as earlier we had considered that whatever body which is there in the second frame is at rest. So now the body which is there in the second frame is not at rest, but it is moving with respect to second frame with the velocity w, with respect to first frame the velocity u. In fact, you have to find the relation between u, v and w. That's what we want to find. Now consider the inverse Lorentz transformation of velocities. We have written this ux equal to ux dash plus v divided 1 plus v by c square ux. Now here the v is the velocity with which the second frame is moving with respect to the first frame. Okay. Then the this u is the velocity with velocity of the third frame with respect to the first frame. So this u will be equal to ux. So ux equal to u. Okay. Then this third frame is moving with respect to second frame with the velocity w. So ux dash will be equal to w. See, ux dash, that is velocity with which some body in the second frame is moving. So that is w. And u, that is ux, the velocity with which the third frame is moving into the first frame. So now we substitute here. And what you get is u equal to w plus v divided by 1 plus v w by c square. Now, otherwise, in the our ordinary life, this u should be equal to v plus w. But see, u is not equal to v plus w, but there is some in the denominator quantity more than 1. So u is less than w plus v. So this is because of the relativity. Now this formula u equal to w plus v by 1 plus vw by c square is Einstein's law of velocity addition. Again, this is true for when the bodies are moving with very high speed. Such thing will happen. Otherwise, in ordinary life, u will be equal to w plus v. Now, to solve this type of problem, see this problem 1. Two electrons are radioactive sample in opposite direction, each having the speed of 0.67 c. C means velocity of light relative to the sample. Find the relative velocity of one electron relative to the other electron. So now what we have are the two electrons and beside that sample. So what we require is the three frames. See, the radioactive sample is at rest. Two electrons are moving each other uh, relative to the sample in opposite direction. Okay, so we require three frames, and you should know that Einstein's velocity addition uh, law. Okay, so three frames: s dash, s double dash. Then v is the velocity second frame with respect to first frame. W is the velocity third frame with the second frame, and u is the velocity of the third frame with respect to first frame. So now what you do here is first you have to draw this. You draw the sample of radioactive material. It is here. Now from this radioactive material, electrons are emitted in opposite direction. So that means one electron is uh, emitted this side and other electron is emitted this side. Okay. So the sample will be in the middle here. So from the sample, the electrons are coming out and moving in the opposite direction. So they are along the line, but one on one side of the sample, other on the uh, other side of the sample. So now once you draw the sample, one electron, another electron, then in this order you mark the uh, frames. This is S, S dash and S double dash. S dash, that reduced sample is there in the frame. One electron in the frame S, other electron in the frame S double dash. Okay. Then we have to use this formula U equal to W plus V by 1 plus V W by C square. So we should know which is U, what is W, what is V. Then see, with respect to sample, this electron is going here with 0.67 C. So with respect second frame, the third frame is moving this way. So here also, with respect second frame, third frame is moving this way in the direction shown here with the W, velocity W. So W will be equal to plus 0.67 C. Suppose it was just opposite to this, but here W is in this direction, then you should have taken minus. But here what happened is, the velocity to which the third frame is moving with respect to the second frame, so velocity these electrons moving with respect to the sample, its direction is same as that of the W as is marked in the original diagram. So W is plus 0.67 C. Then this, uh, with respect to second frame, the first frame, that electron moves this way. That means with respect to the first frame, that is electron, sample is moving this way, opposite. Okay. So that means, say in this diagram, the velocity of the second frame with respect to first frame is v in this direction toward the right. So here this 0.67 is the velocity of the first frame with respect to second frame. So velocity of the second frame with respect to first frame will be same value but in opposite direction. That means toward the right. So again here this velocity of 0.67 c of the second sample with respect to the first electron is same as that of the v which is marked in the original diagram. So it is 0 plus 0.67 c. Now what you want to find is the relative velocity of one electron relative to an electron. So at what speed this electron moving with respect to this electron? That means at what speed the third electron is that second electron moving with respect to first electron. So nothing but with what velocity third frame is moving with respect to first frame, and that is nothing but u. So substitute here and find out what is the value of u. So this is how to solve this problem 1. Now, in the second problem, see, a man on the moon observed two spaceships coming towards him from opposite direction. So, spaceships coming towards him from opposite direction. That means the man on the moon is in the middle, and from one side, one spaceship is coming towards him, and other side, the other spaceship is coming to him. So that is what we draw here. Moon, a person standing on the moon, and one spaceship is coming toward this observer on the moon, and other spaceship also is coming toward that observer in this direction. So that's what is mentioned here. A man on the moon observed two spaceships coming towards him. See, they are coming towards him in opposite direction. So this is the frame S and frame S double dash are in opposite direction. So now, as in our original derivation, the frames are drawn. The first frame is S, second is S dash, third is S double dash. Then let us find. We'll use this formula, u equal to w plus v by 1 plus vw by c square. We'll find what is u, what is v, and what is w. Okay. Now here these see they are coming at the speed of 0.8 c and 0.9 c. This is they are coming at this observer on the moon. They are coming at 0.8 c and 0.9 c. So now this 0.8 c is the velocity with which the first frame is coming toward the second frame. So here we are given that second frame is coming uh, uh, the second frame is uh, going away from the first frame. Second frame is going away from the first frame with the velocity v. So here what happens is that uh, first frame is coming toward the second frame. So that means with respect to second frame, first frame is coming towards him. That means with respect to the first frame, the second frame is coming towards the S, first frame. That means observer on the moon appear to come towards the spaceship S. Okay. So now this 0.8 c is in this direction, whereas here this velocity v is in the just opposite direction. So the magnitude of that v is 0.8 c, but sign should be minus, because theoretically, according to derivation, the velocity of v is from s to s dash. But here the velocity which is given of the second frame with the first frame is in the opposite direction. See, this arrow is first frame with respect to second frame, but what is given in the theory is second frame with respect to first frame, so it is just opposite. So that is 0.8 c in this direction, but actually we want in this direction, so that's why we take a minus sign. Then next is, see, this is coming toward this, the third frame s double dash coming toward the s dash, toward this. So see, third and second, it is w, but third frame is going to the right with respect to the second frame. But here, third frame is coming toward the second frame toward the left. So they are opposite direction. So you have to take minus sign and 0.9 c. Then u is the velocity with which the third frame is moving with respect to first frame. And that's what you know. What is the speed of one space relative to other spaceship? That means what is the speed with which the frame s double dash is moving with respect to frame s. So you have to find out u. So now in this case, you substitute along with the minus sign and calculate that u. Now in this problem, two electrons approach each other with velocity 0.7 c relative to the observer. See, the two electrons are approaching each other. One electron is approaching the other electron. See, the two electrons are not approaching the observer, but two electrons are approaching each other with velocity 0.7 c related to observer. That means, see, these two electrons are there. They're approaching each other. See, we have shown the direction this way and this way. So where is the observer? Observer is here. So observer sees that the two electrons are approaching towards each other. So now you do first is the observer, first electron, second electron. So mark this as the first frame S, second frame S dash, third frame S double dash. Now this here, uh, what you want to find is calculate the relative velocity of the electrons. Calculate the relative velocity of the electron. Now this say, now these velocities are relative with the observer. So that means this velocity is related to the first frame and this velocity also related with the first frame. So this is the second frame, third frame. So now here we find that second frame is moving toward the right with velocity 0.7 c with respect to first frame. So here we know that second frame is moving toward the right with respect to first frame with velocity v. So that means the v equal to plus 0.7 c. See, second electron is going away from the observer in this direction, same as v. Okay, so it is plus 0.7 c. Then the observer sees that second electron, that means third frame, is moving with respect to the first frame with the velocity 0.7 c, but it is coming towards the observer, whereas this third frame and first frame is away from the observer. So this velocity 0.7 is u, but sign opposite, because this is toward the first frame, whereas this is away from the first frame. So you have to take u equal to minus 0.7 c. Then you have to calculate the relative velocity of the electron. So velocity at which the one electron moves with respect to the other electron, that means velocity of the third frame moves with respect to the second frame. So that is nothing but the W. So W you have to find out. So we are given V and U, and W, U and V are given, W you have to find out. So this is how to solve this problem.